Hey there, my name's Scott, and today I'm going to be showing how to do a custom post-processing effect in Unity with the built-in render pipeline. One word of note though, if you want to use the universal render pipeline or HDRP, those projects use a different post-processing stack, so this tutorial will be not applicable to those projects. What I'm going to do today is build an effect for my game Toilet Run. It's a game where you're running to find a toilet, and if you run out of time, I want to have this kind of blurry screen with a pulsating red color to show that you're in danger. So this is what I'm going to be building it for, and I'm going to put the code up in GitHub, and I'm also going to put this effect itself on the Unity Asset Store for free. So if you just want to reference the code or you just want to use the effect, feel free to do so, and you can skip this long video. But in this video, what I want to do is actually explain how it works, starting with an easier version of the shader, and then we'll go into the longer version of it. So basically, when you build a post-processing effect, we need two things. We need a fragment shader, and we need the scripts that go around it. A fragment shader is basically a shader that can let you make changes to particular pixels on the screen, as opposed to, for example, a vertex shader, which is more about on the geometry. So the fragment shaders are generally farther down in the render pipeline, really good for post-processing effects. To start with, I'm just going to make two files. I'll make a script file, I'll make a shader file. I'm going to use the create thing here, and I'm just going to delete the stuff it comes with. So where we got? So we'll go to shaders here, and I'm just going to pick a standard service shader. I'll call it my effect. Sounds good enough, right? I'm also going to make a script file on a behavior script. I'll also call it the same thing. And as I mentioned, I am just going to delete the contents of these files and kind of start with my own here. So let me bring this out here 1 second. There you go, just getting it on my screen. We got this one. That's the standard shader. We also got this script here. Sorry. Yep. Coming up. And like I said, let's just delete it. Let's get rid of this stuff. All right. Now, we'll start with the scripts because I think it's a little bit more easy to understand. Basically, in your script, you're going to need two different classes. The first one is this here. It is the name my effect, and it's inheriting from post-processing effect settings. So what this is this is actually the editor part of your post-processing effect. It's the parameters that you're able to change for your effect. And as you notice, just to keep things simple, I only have one parameter here. I'm making a float value called color intensity, and I'm giving it a default value of 0.2. So this is going to be how much of a color overlay I'm putting on all the pixels on the screen. So once I have essentially my editor, my settings class, here's kind of where the meat comes in. I also have, if I have my effect, I have a my effect render, which is derived from post-processing effect renderer. Notice the type is my effect for the settings that I just used. So there's this connection here. And really, we only, at the bare basics, need to override one function, which is this render function. And this render function is going to be doing two things. One is going to be passing this intensity value to our shader, and it does that here. So first what we do is, you notice we're finding a shader of the name of my folder effect. We'll talk about this a little bit later, don't worry about it. And we get the property sheet for the shader. And in that property sheet, we have this property called color intensity that I've made, and I'm setting it to this value that's coming from the editor. And then I'm just calling the shader, basically. This is what I'm doing. So I guess the important point to note here is that these names all have to tie up, right? I have my effect. I have my effect here in the type, etc., etc. I have my folder, my effect here. This is the folder that your effects will be in. I'll show you what this looks like in a second. Basically, the standard post-processing effects are all in the folder called Unity. You could actually put it in that if you want to, but obviously it makes sense to kind of categorize it. And yeah, that's it. So that's really the scripts. Very, very simple. Now we're going to get into the shader part, which is a little bit more complicated. So this is written in a different language. It's a high-level shading language that is a bit complicated to understand, but we can walk through and it's not too bad. And to be blunt, you really don't need to understand all the details to be able to write shaders, as long as you understand a couple of the key concepts. So first, the easy one, we'll start at the top. You notice the shader name, which is the exact same name as I'm finding here in my script when I'm trying to get the property sheet for the shader. That's obviously important. It needs to match up. Then we have this bottom part, which really you're not going to have to touch. Whenever you're doing a fragment shader, this is basically, you can copy and paste this. Without getting too much into the details of it, you can notice, for example, here that I'm calling this frag function, which is here. This is the main function for the fragment shader. And what it's doing is it's being called on each pixel to do updates to those pixels. So I get a pixel and I make some adjustments to it, and then I return the result of that. If we go in here and look at the top, this is just some standard includes that we need. And this is kind of important. You notice that I have this color intensity value, which happens to match up with this color intensity value. So you can kind of see what this is doing, right? I'm taking the color intensity float from the editor, I'm passing it to this value in what is called the property sheet, which is mapping to this same value that's in the shader. So if you want to add other properties to your shader, you do it in a similar way. You just add other variables and map them from the editor through the renderer and then pass it like that. Okay, here's the key piece of it though. So we have this fragment function. This is basically taking, we're sampling the texture here. So you see I is my input thing, my texture coordinate. And what this is doing, to making it really simple, is I'm just getting the particular pixel we're looking at. It's a float 4, so we're getting the RGBA values of that pixel. And if I just returned it, this shader would be doing nothing, right? It would just be grabbing the pixel and then returning it as is. What I'm doing though is I'm going to make a change to that pixel and then return it, which will then add the effect on. So in this particular case, I'm going to do a lerp. So this is the original RGB of this color, right? And then I have a red color, one for red, RGB, right? So red, this is intensity 1, this is a red color. And then this here is the strength of the blend between these two colors, which I'm pulling from the parameter that we're using for the effect. Obviously what this means is that if I turn the intensity up to 1, it'll be like a full-on blend. If I change it to 0.5, it's halfway, etc., right? But very simple, right? Essentially what I'm doing is taking my original pixel color, and then I'm blending it with this red color here by an intensity value. Now all we have to do is we just have to add this effect that we built into our post-processing stack. So I won't go into too much details on this because it's out of scope of the tutorial, but you know that if you want to use post-processing with the built-in render pipeline, you have to go to the package manager and install post-processing from Unity as a separate package, and then you add that to your main camera here. So the post-processing layer and also a post-processing volume, which is where your effects go. So I will close this up. You'll notice we have the standard post-processing effects here under Unity. I also have this new folder that I've made, my folder with my effect. This is our effect that we just created. All I got to do is add it. And as you can see, we have a nice little overlaying kind of red color to it that's driven by this one parameter for color intensity. Since this is a editable parameter, I can override this and make adjustments to it to add more color if I want all towards completely red, right? So this is the basics. What we've done here is we've taken each of the pixels and we blended it with a red color. So now that we've built a basic post-processing effect, I'm going to expand on that for the effect that we want for this game. And we need to make two enhancements. First of all, we need to take that static color overlay and we need to make it pulsate, which means that we need to reference some sort of time variable within the shader. So I'll show how to do that. The second part is a little bit more complex. We're going to try to do some trails or some blur effect, and to do that, I'm going to be blending past pixels with the current pixels. And I had a lot of trouble finding references online on how to do this. I came up with an approach here that I'm going to be showing. Hopefully this is a reference not just for this effect, but for other effects where you want to reference previous passes of pixel data. But to start with, It's really simple, right? So I've added a bunch of extra parameters. We just had the float before. You can see rather than having red for the overlay, I've made it where you can set a color to use that. So any color that you want for the overlay. Also, for example, pulsation speed, things like that. It works in a very similar way as just our float before, where we set these in the editor here in this part, and we pass that in the render function to the shader, which then maps to these variables here in the shader. So very, very similar to what we did with the float before. The more complicated part is the previous pixel data. So now what I do with this is I'm making this new variable in our rendering class called previous frame, which is a type of render texture. And I also have a render target identification number that's associated with that frame. And to set that up, I need to override the init function and do some fancy things. I need to set, the width, the height, etc., and set the identifier for that frame. I do all this here in this piece. Now, for the render function itself, actually, it's not that different. I'm passing the extra parameters to the shader that I've added, but the only thing really I'm doing beyond what we were doing before is this bottom line here, where I'm essentially, after I do the render, I'm then saving that render to the render texture previous frame variable here, based on the ID that I've set for that. And then if you notice here, I'm actually passing that to the shader. So the first time I pass it here, this is going to be the pixels from the last pass. I do the render, and then I set it, so then the next time I go through, I'll be passing, once again, the previous pass into the shader in this previous frame text. Now, if you look inside of the shader itself, it really hasn't changed all that much. The bottom part is exactly the same. I've added a couple of extra variables, including this new previous frame text, which was the previous textures, very similar to how I had the main textures before. So before I was just sampling the current pixel. Now I'm actually sampling the current and the previous pixel. And within the frag function, you can see what I'm doing with this. I have two blocks of code essentially. So the first one is I'm taking the current pixel as I was doing before, exactly the same. But if my blur is turned on, if I have an intensity that's greater than 0, I'm also sampling the previous pixel. And I'm blending them together based on this blur strength variable that I'm passing in. So this section here is just saying that previous pixel, current pixel, and I blend them together to some intensity. And that gives me that kind of blur effect. The second part is the color overlay, which I've also enhanced. So before, we were doing something like this, except for it was only red. You notice now that it's not just red, it's setting it to the color that I set as a parameter here. So it could be red, green, purple, whatever you want. And it's set to this level. Now this is the other thing that's new. Rather than setting it to a static level, I'm setting it to this kind of like pulsating level. And the way that I'm doing this is that I am taking the amount of time that's passing, and this is a special variable here, this underbar time. What this is this is the expired time. And I'm passing this inside of a sine function. So what this will look like is this kind of like up and down value, right? So as time expires, I'll go up, I'll go back down, I'll go up and back down. And I'm just normalizing this to a value between 0 and the maximum value that I've set as a parameter. So from 0 to 0.5, 0 to 0.4, whatever I've set for that. And then I'm using that level to blend the overlay color. So what we'll get is that over time, we'll get this kind of like pulsation that goes up and down. And this is based on this pulsation speed that I also pass in as a parameter. Now, one thing I'll mention is rather than using underbar time, there's actually an underbar like sine function as well that we could use. The reason why I'm using the time though is because I want to be able to adjust the wavelength of it, right? Like I don't want to have like a static wavelength. I wanted to be able to change the speed of this, which is why I'm taking the expired time and I'm calculating the sine function myself, multiplying by this speed variable. And this is how I get that effect. So that's really it though. It's basically the same before, except for I have some new parameters. I'm blurring here with this previous pixel that we had, and the overlay I can set the color, and it's kind of fluctuating based on this sine function of the time variable. Now if we actually try this out, we can go to add effect, and I'm going to put the color in here. I'm going to go ahead and start it because it looks a little bit worse in the editor, and we can kind of adjust some of the parameters and see how it functions, right? As you can see here, I have 1, 2, 3, 4, 5 different parameters I've created. We have the overlay color. It's set default red, but I can change it to other colors. We can also change the intensity of that, enable it, disable it. It's red at the moment by default. I can change this, for example, to maybe a yellow color or a green color if we want. I can lower or increase the intensity of that pulsation if I want. I can change, for example, the speed of the pulsation, make it very fast, make it very slow. And I can also work on the strength of the blur as well. Let me see if I can turn some of this off a little bit. So if I turn the intensity down to 0, we shouldn't have any overlay. And I can adjust the strength of the blur. So this is, at the moment, it's like 0.8, so it's a pretty strong one. I can drag this down, and you can see the blur kind of goes away. If I pull it back up, you'll start getting the trails up until this kind of extreme version of it. So this is how the effect works. Not that different from the original post-processing effect that we made. And as I mentioned, I have this up on the Unity Asset Store. If you just want to use it as is, you can go there and download it. I got the link in the description. If you want to look at the code, I also have it in Git. You can check the code out and make some modifications. But I do think this is a really good base for a wide variety of post-processing effects that you can do. Have a play, have fun with it. Hopefully this has been of some reference. And thank you so much for your time and for paying attention. Take care.